Hey guys, welcome back to General Chemistry 1. Today we are going to get to know the periodic table just a little bit better. Now that we have a solid understanding of electrons, we're just going to get to know how the periodic table can help us and just some terms and whatnot that I'll be using through the duration of the semester. All right, so first, kind of the history of the periodic table. How did we get it together? So both Mendeleev and Meyer are published tables that arrange the elements according to atomic mass. For whatever reason, Mendeleev is the one that's always credited with him, but there were other scientists out there that were working on this same material and other ones that published it the same way that he did. He just tends to get credit. I don't know. Mendeleev used his tables to predict the existence of elements. So pretty cool. If we're arranging them based on atomic mass, he was able to leave holes in his periodic table. He would say, here's atomic mass of this. I think something goes here. I'm pretty sure something goes here, but I know this other one on the other side. Well, by leaving a hole in the periodic table, we could then predict what that might look like, what the atomic mass might be, what some of the properties might be. And it's a lot easier to set up an experiment if you kind of know what you're looking for. So with his establishment of the periodic table and then using those holes as predictive cues, the discovery of elements during this time just absolutely blew up. And then it gives two examples. So discovery of gallium and germanium were provided great support for Mendeleev's work. So here's just kind of a picture of what his periodic table started to look like. Not as beautiful as ours is today, but to him, it made sense. So he's got his different groups, it looks like here, 1, 2, and 3, so on and so forth. And then he's got his different elements within those groups. Here's where we see those spaces that he left. So we see spaces kind of all scattered throughout. So for example, if I know aluminum and its properties, I know something else is going to look a lot like aluminum and have a lot of the similar properties. It's a lot easier to predict and set up experiments to find that. So here's kind of the beginnings of the periodic table. So our modern periodic table, what we see now, the much more beautiful version, by the 20th century, it became apparent that periodic relationship and atomic numbers were better connected than atomic masses. So if you look at the periodic table that we have now, it is arranged according to atomic number. If you look at the masses, for the most part, the atomic masses do continually rise. There are a couple just odd, quirky examples where the atomic mass will go up, up, down, up, up, up. So there are some quirky examples. So that's why atomic number was a better way. The properties of elements are periodic functions of their atomic numbers. So a lot of these properties repeat. And then the modern periodic table arranges the elements in increasing order. And then we've got vertical columns. We've got horizontal columns. The vertical columns, well, I'll talk about those on the next slide. Okay. So here's just kind of a way that we can visualize how this periodic table came together. So here's what Mendeleev had to deal with. He had a bunch of elements that were discovered, and we're like, man, how am I going to organize all this information? What's one way that I can start to organize them? So one of the things that they did is they started looking at the properties of these elements. And what they noticed is the elements had similar properties, and those were properties repeated like every 8 elements or so. What kind of properties am I talking about? Things like, does it conduct electricity? Is it a solid at room temperature? What's its boiling point? What's its melting point? Things like that. Does it react in a certain way? And what they noticed is these elements started to repeat, the properties started to repeat every 8 elements or so. Much like an octave in music, so about every 8 notes, they repeat themselves. Periodic table is very similar. So what they started to do is they started to stack these elements one on top of the other. based on these repetitive properties. And now you can start to see this periodic table takes shape. They didn't necessarily do it the same way that we have it now. So we have families across the top and periods down the side. They actually had it flip-flopped at first, and then they rearranged it, and you see the periodic table we have now. So here is our modern periodic table. I'm going to just go through a series of slides that are strategically colored and talk about some terms that are very important that you'll need to know. So first thing we see here are some different colored rows. So, grab my laser pointer. These rows that are up and down, those I like to call families or groups. So they're families or groups. Just like your family, these elements all have the same or similar characteristics or similar properties. So if everybody in the family has similar characteristics, we know that they go together. Okay. There's going to be 4 families that are important that you guys know. The 4 families are the alkali metals, alkaline earth metals, jump across the other side, halogens, and we've already talked about these guys, the noble gases. So it's going to be important that you know the names of those. They're going to be the elements we probably deal with the most often, and they're very important elements. The other thing I want to point out here is these guys in the middle. So I told you they're odd, they're weird. Now we can see their name. They're called the transition metals or transition elements. And they will still march to the beat of their own drum. Here's just another look. This is a graphic from your text, the same information. So alkali, alkaline, transition, noble, halogens. In this beautifully colored periodic table, we see the difference between the P block, S block, and the transition elements. So P block, S block, they're all colored yellow in this picture. Those are called our main group elements. So our main group elements are very predictive, very deterministic. They follow the rules that we have asked them to follow, and there are no deviations from those rules for the most part. The exceptions to the rule are colored in blue on this one, the transition metals or transition elements. These guys march to the beat of their own drum. So we will learn, hey, here's how things work for the main group elements. Oh, and here's how the transition elements don't follow those rules. So they're always the exception to the rule. The last category that I want you guys to know, and this one is so incredibly vital. So your ability to recognize this one quickly will set you up to be very successful in the next chapter. If you cannot identify metal and non-metal quickly, you will not do well in the next chapter. So please make sure you know this one. So we've got all of these tan elements on the left-hand side of the periodic table. All of these tan elements are known as metals. So metals are exactly what you would predict. So if you close your eyes and picture a metal, it's shiny, it's malleable, we can bend it and shape it. It will conduct electricity, it will conduct heat. It's a solid at room temperature. So all of those tan ones are considered metals and have those similar characteristics. This teeny tiny little section of the periodic table up here, those are our non-metals. So our non-metals are everything that metals are not. So our non-metals are gases at room temperature. They do not conduct electricity. They do not conduct heat. So those are our non-metals. Why that looks like a really small portion of the periodic table, actually our non-metals have a really, really big chemistry. So if you've heard of something called organic chemistry, when you take that course, you will live in just the blue section of this periodic table. So it's a whole course based just on the blue section there. So huge chemistry. The green guys down the middle. So these green guys are stair-stepping through. Those are our metalloids, or semiconductors. So our metalloids are just kind of the transition from metal to non-metal. So most of them are solid at room temperature. Will they conduct electricity? Yeah, but not very good. Will they conduct heat? Yeah, but not well. So they're just kind of that passing through from a metal to a non-metal. Okay. So that is where we're going to end about our discussion on the periodic table. Just make sure you're familiar with those different regions, because in future lectures, I'm just going to say metals or non-metals. I'm going to say main group, or I'm going to say transitions, and it's up to you to know where those are located on the periodic table. I hope you guys found this helpful.